Hi everyone, we're going to go ahead and review the chain rule. In class we used the Oreo cookie to kind of have a memorable moment and remember the chain rule as d outer, d stuff, where we took the derivative of the outside function and multiplied it by the derivative of the inside function. But to review what this really means, it basically means we're taking functions and writing them as a composition of functions. We're taking a function like 3x squared minus 7 raised to the 5th power and expressing it as a composition of functions, and then taking the derivative. So, if in this function we can go ahead and say, ooh, I see two functions in here. I see x to the 5th, and let's call that f of x. And I see 3x squared minus 7, and let's call that g of x. And what's really happening is that g of x is going inside f of x, so f of g of x is 3x squared minus 7 to the 5th. And now I want to take the derivative of this function. Well, instead of taking 3x squared minus 7 and multiplying it by itself 5 times and then taking the derivative, we can use what's called the chain rule. And the derivative of f of g of x, the derivative of f of g of x is f prime of g of x multiplied by g prime of x. D outer, d stuff, the derivative of the outside function multiplied by the derivative of the inside function. So how would this look for a question like this? Well, since the outside function is something to the 5th power, we'll use our power rule. So 5 multiplied by, it's still the same. So we're really not touching 3x squared minus 7. So we're going to do the power rule, let's say on the parentheses. 5 comes down, n x to the n minus 1. So n x to the n minus 1. And then there's our d outer and our d stuff. D stuff is the derivative of what's inside. So that is 6x. And then bring this in here. So f prime of g with g of x, f prime of g of x. So g of x is still staying in there. We're just doing the derivative, this big outside function, which is basically an x to the 5th. And then multiplying it by the derivative of what's inside. Clean that up to be 30x with 3x squared minus 7, or multiplied by 3x squared minus 7 raised to the 4th power. So let's do some more from our manual. So here we are in the manual for lesson 9, the chain rule. I'd like you guys to take some time to work through A, B, C, and D on your own. Those should be pretty quick. Also rewriting D as 2x plus 5 to the 1/2 power so that you can properly apply the chain rule. On this page, also important to note is the formal definition of the chain rule that we just talked about, and a description of the chain rule in case you are still needing a little more clarity on the chain rule itself. But all of these are situations where you would be using the chain rule. On the bottom of the page, you have more situations where you're using the chain rule. Looks like we've already done one like this, so you can do number 3. We would do number 3 by rewriting that as 2x minus 5 to the negative 2 power. So we would definitely be wanting to use the chain rule here as opposed to the quotient rule. Moving along to the next page. We would be wanting to use chain rule all along the way for 5 and 6 instead of quotient rule. Rewriting that function as f of x equals 4x, there we go, 4x minus 3 to the negative 1. Rewriting here as well, this function as 3 multiplied to this quadratic raised to the negative 3rd power. So we've already done a few of these types of problems in class. So I would use this opportunity to practice a few of them, or practice the ones that you feel you have difficulties with, and then you can check your answers on Monday with those. So I'd like to actually take a look at different types of questions. And basically, noting here that we have 3 basic forms for differentiation. Okay, other than when we are taking the derivative of a constant, we have 3 basic forms for differentiation. You're either looking at a power rule, which is an expression to a power. You're looking at a product rule, which is an expression times an expression, or you're looking at a quotient rule. These are the 3 big umbrellas. The chain rule is not one of the three big umbrellas because the chain rule is always in effect. It's always happening. You're always doing the chain rule. So for example, let's say we're taking the derivative, so let's say f of x is 7x squared, okay? Technically, we're looking at the power rule. Okay, that's the basic form that we're in. But you're still doing the chain rule because if you apply the concept of d outer, d stuff, we do d outer, 14x to the 2 minus 1, and then d stuff would just be 1 because your stuff is x. That's your stuff. And this is d stuff. So since we did the power rule, the power rule is the overlying, kind of rule that's going on here, we still kind of were doing the chain rule. The chain rule is always in effect. We just don't write this d stuff. So I want you to keep that in mind, that you're either really operating on one of these three scenarios and knowing that the chain rule is always in effect. We prefer derivatives in factored form when possible. And yeah, we want to make sure that we are kind of strengthening our algebra skills because you can get problems wrong, not because of the calculus, but because of the algebra, and we've talked about this multiple times. So let's take a look at number 10. All right, so here we are on number 10, and the overlying rule, the big over, umbrella rule here is a product rule. Because we have an expression multiplying to an expression. So to refresh our memory, 1d2, oh, that's not a 2, 1d2 plus 2d1. The first times derivative of the second plus the second times derivative of the first. So the first, or f prime of x equals, let's do our notation, f prime of x equals the first times derivative of the second. Now the derivative of the second is going to require the use of the chain rule. So derivative of the second is 4 2x minus 3 raised to the third. That's d outer, d stuff. That's why people forget the d stuff, because we got a lot of steps happening here. The first times the derivative of the second. The derivative of the second required the use of the chain rule, d outer, d stuff. Okay, the first times derivative of the second plus the second, 2x minus 3 to the fourth, times the derivative of the first. All right, 1d2 plus 2d1. Now we clean. So f prime of x, oh, the calculus is done. Now we do algebra. So f prime of x is 2x squared, nope, it's 8x squared, because of x squared times 4 times 2, 8x squared, multiplied by 2x minus 3 raised to the third, plus 2x multiplied by 2x minus 3 raised to the fourth. All right. So that looks somewhat acceptable, but it looks like we can take out a 2x minus 3 here. So we take out a 2x minus 3 to the third. That leaves us with 8x squared plus 2x multiplied by 2x minus 3. Because since this one was raised to the fourth power and we took 3 of them out, we only have 1 left over, and this guy's just straight up gone. Boom, he's over here. And now we just need to clean up this parentheses. So 8x squared plus 4x squared, that's going to be 12x squared minus 6x. And to the third, and 2x minus 3. They don't have to be brackets, they could be parentheses over there. You can make that parentheses if you'd like. We could take out 6x from here. So let's go ahead and do that. So 6x, 2x minus 3 to the third, and that leaves me with a 2x minus 1. And that is a beautiful, fully factored answer of the derivative. All right. So although this is kind of like you're kind of done with the calculus here, you really want to do a little extra work, this is a better, a more ideal answer. It's a cleaner answer. So go ahead and now try on your own. Try number 11. It is a product rule because you do have an expression multiplying to an expression, and you could check your answer on that one on Monday. Let's keep going. All right, for each of these, I'd like to do a little setup for you, and then you guys kind of finish them off on your own. So if we look at 12, the big rule here, it looks like it's a big power rule, right? We have the whole parentheses around the expression, and we've got the power in there. But looks like when we're going to be doing d out or d stuff, when we go to do d stuff, it looks like we're going to have a quotient rule. So we have here a power rule with also a quotient rule. So our d outer is going to be 5 parentheses 2x minus 1 over 2x plus 1 to the 4th. There's our big power rule that's going on, and that's the d outer. And now when we go to do d stuff, we have to do a quotient rule. So low d high minus high d low all over low squared. All right, so we had the big power rule, so that's our d outer, and then this is our d stuff. So we may want to do some cleaning up here. This is 2x minus 1 raised to the 4th power, 2x plus 1 raised to the 4th power. We are multiplying. We've got some cleaning up we could do here, some distributing and combining of like terms. So go ahead and see how far you can simplify that, and then you can check your answers in the key on Monday. Let's take a look at 13. 13, we will want to rewrite it and use a product rule. Rewrite it by moving this up and making the exponent negative. So rewriting it as f of x is equal to x multiplied by x squared minus 1 to the negative 1/2. And then using a product rule, obviously with a chain rule involved in there as well. Looking at 15, looks like you're going to be just straight up doing a product rule. You're going to use chain rule multiple times here, a couple times, but the overlying rule here is a product rule. So go slow there. And 16 is going to be a lot like 12. So we're going to rewrite 16 all to the 1/2 power, and 14 is going to behave a lot like the one on top of it. So hopefully that gets you set up for those 4 questions so that you can work on them. If you want to pause the video and work on those now, it's great. And we're going to keep moving. I'm going to keep this moving to the derivatives. Over here is kind of like derivatives by table. Even though they didn't give me a table per se, they gave me these values. So our job is to find h prime of 2. And we have the functions here. For example, number 16, we have h of x is equal to f of x raised to the 3rd power. We have to be real careful here. We are doing a power rule here, but the chain rule is always in effect. So we have to do a d out or d stuff. We're always doing d out or d stuff. So 3 f of x to the 2nd, there's our d outer, times our d stuff of f prime of x. So this is really important because it's this that always gets forgotten. And we can't forget that there is stuff in here, and the derivative of this stuff has a value. It's not just 1, like if we were doing x to the 3rd, where we're doing 3x to the 2nd times 1 because our stuff is just x. That's not the case here. Our stuff, in this case, is f of x, and the derivative is f prime of x. So now that we've set up what h prime of x is, now we can find h prime of 3 by plugging in 3 and finding those values in the given statement above. So you can finish that one up. Taking a look at 17, we're going to be doing the same thing. H prime of x is equal to d outer, so 2 f of x minus g of x to the 1st power, because 2 minus 1. All right. And we cannot forget d stuff. That was d outer, and now we need to do d stuff. D stuff is f prime of x minus g prime of x, which is how you take the derivative of a difference. The derivative of a difference is the difference of the derivatives. So d outer times d stuff. And then we would do h prime of 3. Over here, looks like we need a little rewrite. So h of x is equal to all of this raised to the 1/2 power, 4 g of x minus 1. This is overall a big power rule, not forgetting that the chain rule is always in effect, so we need to do our d stuff. There's a lot of stuff in here. So h prime of x is equal to 1/2, 4 times g of x minus 1 to the negative 1/2. That's d outer. Now our d stuff is 4g prime of x minus 1 minus the derivative of this one, which is just 0. So 4g prime of x is the derivative of this one right here, minus the derivative of x, which is 1, minus 0. And now we can evaluate h prime of 3. So I would like you to try 19, 20, and 21. Keep in mind that these are compositions of functions, so you are literally doing d outer d stuff, d outer d stuff, d outer d stuff, okay? And then you can check your answers to those on Monday. So that is the end. That concludes this video. On Monday, we are going to review your tests. We're going to review the chain rule, and I do have a joke to close off this video. So here is a joke. The joke is, what do organic mathematicians throw into their fireplaces? What do organic mathematicians throw into their fireplaces? The answer, natural logs. Ha ha. Alright guys, that's Miss B signing out.